For today's video, we're going to go over graphing linear equations. I may have shown how to graph some equations in some previous videos, but this is where I'm going to formally introduce it. And so, to start graphing a linear equation, we really need it in slope-intercept form. And so remember, slope-intercept form looks like y is equal to mx plus b. Okay, it helps a lot when we get it into slope-intercept form. You don't exactly need it, but it really helps to put it into slope-intercept form. So we're going to have an example that we're going to start with, and I'll show you how to graph a linear equation if you don't already know. So the example problem that I want to start with will be in standard form, which is 2x plus 4y is equal to 6. Okay, first thing I'm going to do is I'm going to convert it to slope-intercept form, and then we're going to get some points. So I'm going to start by subtracting the 2x, and so I'm going to get 4y is equal to negative 2x, whoops, wrong color, right color, plus 6. Okay, then I'm going to divide by the constant 4. And I'm really just going to multiply by 1/4 on both sides. And to simplify this whole thing out, I'm just going to have y is equal to negative 1/2 x plus 3/2. Okay, that's the equation I want to work with. Now, when you're solving and when you're trying to graph a linear equation, we use a form called a t-chart, or I like to call it a t-chart, where it has x's on one side and y's on the other side. So that way we know coordinate points. For example, one coordinate point I can choose is the y-intercept. So when x is 0, if I plug in 0 here into y equals mx plus b negative 1/2 x plus 3/2, I know my y value is going to be 3/2. Additionally, when I plug in 1 for x, I'm going to get negative 1/2 plus 3/2 x. And so then I'm just going to get negative 1/2 plus 3/2. That will give me 1. Because negative 1 plus 3 is 2. 2 over 2 is 1. Okay, and then if I were to plug in 2 for x, then I would get negative 1/2 times 2, which is negative 2 over 2, which is just 1. And then negative 1 plus 3/2 would get me 1/2. And so using this t-chart, I can get 3 points that I can then graph. And so if I draw my coordinate grid here, and I will just label these 1, 2, 3. I'm going to try and space them out evenly, but I am not a proficient drawer. 2, 3. I can then use these 3 points I have over here, 0 3/2, 1 1, and 2 1/2, to get a good graph. So 0 3/2, I'll do it in light blue. That is approximately right here, between 1 and 2 on my y-axis and at 0 on my x-axis. 1 and 1 is easy to find. That's in the first quadrant. And then 2 1/2 is right about here. And so then if I want to draw a line between these 3 points, I'll get something that looks like this. And this is the equation of the line that I'm working with. Okay? Now additionally, if you are inclined, you can use the slope of -1/2. And you can realize that this is rise over run. So you'll go down 1 over 2, down 1 over 2. So you would effectively go down 1. Oops, let me do this in a different color. Down 1. So you would go from 3/2 to 1/2, which is right around here, and then over 2 spots. And you would get this point if you were using the slope. Either one works. Technically, using the slope form is quicker, but I really like to use the T-chart because it's very formal, it's definitive, and if you need to have multiple points, because sometimes people just put 2 points and then they'll have kind of an awkwardly shaped graph. Having more than 2 points or having 5 points can really make your graph look a lot nicer and a lot cleaner. And we'll see that much more useful when we get to things like parabolas and other quadratic shapes. Now, we can also do the exact opposite, is we can find the equation of a line from a graph. So this way what we just did now is we took an equation and graphed it. Now we can go from a graph to an equation. So I'm going to go ahead and write another example that we have. I'll start with my graph. I'm going to have 1, 2, 3, 4. 1, 2, 3. Go and label these. And then I'm going to have a point here. And I'm going to have a point here. And I'm going to draw a line between the two. So we get something that looks like that. Okay, so suppose you have a problem where you're asked, find the equation of the line of this graph, and you have this line with these 2 points that I'm dotting in red. Now, the way I like to do this is I like to look at the equation y equals mx plus b, so I'm just going to write that down below. Y is equal to mx plus b, and I like to fill it in. So what that means is m is my slope, and b is my y-intercept. So the first thing I like to do is I like to find what my y-intercept is. From this graph, I can see that my y-intercept is right here, and it is 0, 1, where x is 0, y is 1. And so I'm going to plug that in for b right here. My b value is going to be 1. Now my slope in this case, our slope m, is equivalent to rise over run, if you've heard that from your teachers. If you haven't, well, you've heard it from me, and I'll show you what that means. That means how many places do we go up and then over to get to the next point? So in this case, in order to get to this next red point up here, we go up 2 and then over 1. So that means we go up 2 over 1. And so in this case, our rise, which is how much up we have, and then our run, which is how much over we have, that is equivalent to 2 over 1, which is just 2. So in this case, my slope now is 2. And so now I can plug in both 2 and 1 into my slope-intercept equation, and I'm going to get y is equal to 2x plus 1. Okay. And so that is the equation of the line. And if we look at it, and if you wanted to double check it, you could then use your T-chart, graph this equation here, and hopefully it should come out to exactly what you started with up here. So if we have 2x plus 1, we see we start at 1, then we use our slope to go up 2 over 1, and we get our next point up 2 over 1, so on and so forth. Okay. The last thing I want to cover in this lecture is some unique lines, specifically what a horizontal, a vertical, and an origin line look like. After that, we'll go over some examples in the next video that I think will be more interesting. But for today, I want to finish off with, let's talk about horizontal and vertical lines. If I could spell, that would be amazing, but I'm a math major, so pardon the typo. So a horizontal line, and I'm just going to give you a brief example of what they look like. A horizontal line will look something like this, where it's y is equal to a constant. And that constant we'll just say is c. An example of that would be y is equal to 1. And if I were to graph this, it would look something like this, where I have my coordinate plane, I have my x line, my y line, my x-axis and my y-axis. I dot out what 1 is, because I'm saying y is equal to 1, so I need to know where 1 is. Here it is on my y-axis. And then a horizontal line simply goes across y is equal to 1. And if you know something from geometry, this line will be parallel to the x-axis. Okay? And that is what y equals 1 look like. Okay? Now, a vertical line will be something very similar, except it's going to look really odd from what we're used to seeing. And the reason why it looks odd is because it starts with x. So it'll be x is equal to some constant c. What that constant is, we don't know. But a great example would be x being equal to 2. That's a good example. Let me draw a little bit of a better 2 there. There we go. And if I were to graph this, it would look something like this. So let me get my x-axis, my y-axis. Oops, this is my y. This is my x. If I have 1, 2, my x line would then be starting at 2 and going up and down across it. And this line will be parallel to my y-axis. And so here is x equal to 2. Okay, and so that covers horizontal and vertical lines. I'm going to show you one final line, which is going to go through the origin. And so this is a special type of graph where we go through the origin, and we have a y-intercept, but our y-intercept in this case is the origin itself. And so I'm just going to type a line going through origin. Technically, it does not have a formal name. I tend to call them origin lines, but that's not formal. It's really just a line going through the origin. There's nothing too fancy about it, but it looks something like this. Y is equal to cx, where c is a constant. And so a good example of that would be y is equal to 4x. And if I were to graph this, it would look something like this. Here's my y-axis, here's my x-axis. 1, 2, 3, 4. So here, we don't have a y-intercept. And so I just have y is equal to 4x. So if I wanted to use a really quick t-chart, where I have my x's and my y's, if I let x be 0, then I plug in 0 for x. 4 times 0 is just 0. If I let x be 1, I then get 4 times 1, and y is 4. Now you can continue this process to get more lines, but just for simplicity, to get more points. But just for simplicity, I'm just going to use 2 points here. And my line will look something like this. So I'm going to have 1 point at 0, 0, which is known as the origin. And then my other point will be up 4 over 1, right around here somewhere. And if I draw a line connecting them, there is my line through the origin. Y is equal to 4x. Whoops. 4x. Okay. So in the next video, we'll go over some examples of graphing. It'll cover what we did in this video, but more to an extent, or to a bigger extent, and we'll have some problems to go over, which will be nice.